So let us discuss about the discharging of the capacitor. This is similar to charging. So derivation is similar to charging, but here battery is not connected. Battery is disconnected. So this is the circuit. Only resistance is connected to capacitor and a switch is there. Initially, capacitor is fully charged. Suppose if fully charged capacitor is connected in series with the resistor along with the switch, the capacitor discharges through resistor if switch is closed. If switch ನೀವು close ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ capacitor will send the current in the circuit and charges will start to flow. And finally, capacitor discharges. So now capacitor acts like a battery. The battery ತರ act ಆಗ್ತದೆ because it has charges and it will send the charges if there is a closed path. Okay. So fully charged capacitor has stored electrical energy and the energy gets dissipated in the resistor in the form of heat and radiation. So energy will be lost in the form of heat. The discharging process takes place for a short time and shows transient phenomena. So current through the circuit will vary. Okay, and that shows transient phenomena. The opposition by the resistor for the flow of charges makes discharging process a control. So resistance will control the flow of charges or it controls the current. Let us circuit which is fully charged capacitor. Then it is connected to a resistor R through a switch. Suppose you close the switch, capacitor start to send the current. The current send ಮಾಡ್ಲಿಕ್ಕೆ start ಮಾಡ್ತದೆ. Okay, so current will flow and let I be the instantaneous current. And at the beginning, this capacitor has charge Q0, maximum charge ಇರ್ತದೆ. And let us take voltage of the capacitor is V0. Initially, the voltage of the capacitor is V0, charge is Q0 because we have to discharge the capacitor which was fully charged. ಈಗ ನಾವು capacitor charge ಆಗಿರೋ capacitor ನ discharge ಮಾಡಬೇಕು. Discharge means you have to connect it to a resistor. ಒಂದು resistor ಗೆ connect ಮಾಡಿದ್ರೆ capacitor ಏನು ಮಾಡ್ತದೆ, it will send the current through the resistor and it will lose its charges. That is called as discharging. Now you analyze, apply KVL here. Let I be the instantaneous discharging current. Current becomes zero. Also, voltage across the capacitor plate reduces to zero from V0. Finally, ಏನಾಗ್ತದೆ, current decrease ಆಗಿ zero ಆಗ್ತದೆ and voltage also becomes zero. But initially, voltage is V0 and I is going to change continuously. Okay, so apply KVL to this loop. Only two components are there. One is resistance, another one is capacitor. So you apply the value here. So here V R equal to I into R. Voltage across the resistor is current into resistance. Voltage across the capacitor is minus Q by C. Why minus Q by C is taken? Minus sign is taken because charge is decreasing, capacitor is discharging. You substitute here, you will get the expression IR is minus Q by C equal to 0. You will get the expression IR minus Q by C. IR is voltage across the resistor, Q by C is the voltage across capacitor. Now we have to apply, you have to solve this equation for Q. You have to find the expression for Q as in charging case. Let us do that. We have IR minus Q by C equal to 0. Now express this current I as minus dq by dt. Negative sign indicates that current is decreasing. Okay, charge is decreasing. That's why current is also decreasing. Current is given by dq by dt with negative sign. Substitute here. We'll substitute matter. I is equal to minus dq by dt and substitute matter. You will get minus R into dq by dt, where minus dq by dt is substituted, minus q by c equal to 0. Now R is constant, C is constant, Q is variable, time is variable. Separate the variables and solve it. So separation of variables gives dq by q is equal to dt by rc. Simple. So just rearrangement ಮಾಡಬೇಕು. Negative sign ನೀವು ಒಂದು ಈ ಕಡೆ ತಗೊಂಡ್ರೆ ಒಂದು ನೆಗೆಟಿವ್ ಸೈನ್ ಹೋಗ್ತದೆ. ಯು ವಿಲ್ ಗೆಟ್ dq by q. ಓಕೆ, ಸಾರಿ, ಇಲ್ಲಿ ಮೈನಸ್ dt by rc ಬರಬೇಕು. ಸಾರಿ, So here you will get so you will get dq by q is equal to minus dt by rc. Okay, r into c ಇಲ್ಲಿ ಬರ್ತದೆ, q ಇಲ್ಲಿ ಬರ್ತದೆ. So just you rearrange ಮಾಡಿದ್ರೆ ಎರಡು ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಬರ್ತದೆ. Okay, just you try to do it yourself, but it is very simple mathematical steps only. Now you have to integrate this. Integrate this equation ಇಲ್ಲಿ with respect to q integrate ಮಾಡ್ರಿ, ಇಲ್ಲಿ with respect to time t integrate ಮಾಡ್ರಿ. So this dq integrate, you will get a dq by q is equal to minus integration of dt by rc. What is the integration of 1 by q? It is ln of q is equal to minus t by rc plus some integration constant. It is an indefinite integration constant you have to get. So simply you will get ln of q is equal to minus t by rc. So put the initial conditions. When t is equal to 0, capacitor was fully charged. So charge on the capacitor q was q naught. That is the maximum charge. Remember, we are discharging the capacitor from the maximum charge. So at t is equal to 0, initially charge q was q naught. Substitute for here and find the value of c. So t is equal to 0 akre ಇದು 0 ಆಗ್ತದೆ. So c will be equal to ln of q naught. So c will be equal to ln of q naught. So take the ln of q naught on the other side and simplify it. You will get q is equal to q naught into e to the power minus t by rc. This is a logarithmic equation. To convert that into exponential equation, you will get q is equal to q naught into e to the power minus t by rc. Okay, this is the expression for charge during the discharging of capacitor. Okay, so now what will be the expression for v and I? They are similar. Discharging ಮಾಡಬೇಕಾದ್ರೆ ವೋಲ್ಟೇಜು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ, ಚಾರ್ಜು ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ, ಕರೆಂಟ್ ಕೂಡ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. What are the expression for voltage? V will be equal to V naught into e to the power minus t by rc. How you can get the equation? Divide this equation by c. Q by c will be V, Q naught by c will be V naught. That is simple. Then to find the expression for I, you differentiate this equation. Then differentiate with respect to time. You will get I is equal to minus I naught into e to the power minus t by rc, where I naught is V naught by R. So I naught is V naught by R, that is the maximum current. So the negative sign indicates that charging current and discharging current are opposite in direction. Okay, charging current nimge I is equal to plus I naught into e to the power minus t by rc anta bandittu, but here discharging current is minus. And finally, put the value of rc, t is equal to rc in this equation. If t is equal to rc, then q will be equal to 0.37 times q naught. So that is the value of 1 by e. The product rc is called as time constant of the circuit. Again, same. Time constant is defined as the time during which charge on the capacitor falls to 0.37 times the maximum charge on it during the discharging. ಇದು ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಸಂಬಂಧಪಟ್ಟಂಗೆ ಬರ್ತದೆ, ಡೋಂಟ್ ಕನ್ಫ್ಯೂಸ್ ಇಟ್. ಚಾರ್ಜಿಂಗ್ ಆಗ್ಬೇಕಾದ್ರೆ 63% ಚಾರ್ಜ್ ಆಗ್ತದೆ at t is equal to rc. ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಆಗ್ಬೇಕಾದ್ರೆ it decreases to 37% when t is equal to rc. Remember this point. Then this is the graph showing the voltage and current variation. Voltage is going to decrease like this. At t is equal to rc, the voltage and charge will be 0.37 times of maximum voltage or maximum charge. But here current is decreasing in the negative direction. Negative agide. Okay, it becomes 0. The negative current is minus current I naught. I naught in the negative direction decrease ಆಗ್ತಾ ಬರ್ತದೆ. Finally it becomes 0. Remember, it comes in fourth quadrant. Okay, fourth quadrant ಅಲ್ಲಿ ಬರ್ತದೆ. So that will be 0.37 I naught when t is equal to rc. Okay, this is about the charging of capacitor. Okay, so just go through the derivation once again. The derivation once note. First, you have to take the circuit.